So, we are starting a new chapter which is sewerage system and sewage appurtenances. We are almost uh, turning towards the end of environment engineering. So, let's finish this chapter also. It will be covered in one lecture only. So, the very first question which came in GATE 2016. See, this chapter is not that important, but yeah, whatever questions came in the previous year exams, we should just solve them out and we should get an idea that what kind of questions can come in the exam. Okay, let's start the first question, which says that crown corrosion in a reinforced sewage concrete is caused by, see, any corrosion is caused by, this is called, if let's say this is your crown, this is your sewage cross section, this is your crown. So crown corrosion is caused by the fumes, the toxic fumes which are generated because of the microorganisms that are present in the sewage. So those toxic fumes create corrosion in the crown. So that is done by the H2S. So the toxic fumes are of H2S. Let's move on. Next question, which is question number 2. Assertion: at a manhole, the crown of the outgoing sewer should not be higher than the crown of the incoming sewer. Okay, that means they are saying that if it is a manhole and this is the incoming sewer and this is the outgoing sewer, okay, there will be lot of incoming sewers coming, adding into this manhole, and this is outgoing and this is incoming. Okay, so they are saying that the crown, that means the head of the incoming should be should not be higher than the head of the crown of the incoming sewer. Outgoing should not be higher than incoming. That means incoming should not be lower than outgoing. This is what they are saying in assertion. And reason they are giving: the transition from a larger diameter incoming sewer to a smaller diameter outgoing sewer at a manhole should not be made. Then they are saying that if the incoming sewer is large and outgoing is small, this transition should not be made. So the assertion and as well as reasoning both are correct, but they are not, but the reason that is given is not for the assertion that is mentioned. See, at a manhole, the crown of outgoing sewer should not be higher than the crown of incoming sewer, because if incoming is on the lower side and outgoing is on the higher side, that means there will be backing up of sewage will back up, there will be backflow, we can say, and this incoming will be choked. So this should be avoided. And then transition from a larger diameter incoming to smaller diameter outgoing, then that also the same reason. If incoming is more and outgoing diameter is small, that means there will be choking, obviously, because diameter is not that much, and from incoming the flow is coming at a higher rate. Okay, so these are the things. So I can say the option B, which is not mentioned here, but the option B should be that assertion and reasoning both are correct, but they are not of the reason is not of the assertion. Okay, let's move on. Next question: a circular sewer 2 meter diameter has to carry a discharge of 2 meter cube. Okay, let's write it. There is a dia of the sewer that is 2 meter. There is a flow that is 2 meter cube per second when flowing nearly full. They are talking about nearly full, or we can say full. The sewer is running full. Now, what is the minimum required slope to initiate the flow? Minimum required slope to initiate the flow. The slope value they want to know, but they have given the Manning's constant, that is 0.015. Okay, see, there is one equation, because Manning's formula, Manning's constant they have given, so we will use Manning's formula, that is Q is equal to V is equal to 1 upon N R to the power 2 by 3 S to the power 1 by 2. And if I want to calculate discharge, so Q is equal to A upon N R to the power 2 by 3 and S to the power 1 by 2. From here I can get the slope. See, I have discharge, I can calculate area, I can calculate R, N is given. So let's calculate the area first. So the area will be, because it's circular, pi by 4 d square, diameter is given, pi by 4 into d square, that means 4. So the area comes out to be pi. Okay, now what is R? R is wetted, that is hydraulic mean depth. It is given by wetted area upon wetted perimeter. So I can say R is equal to A upon P. And for sewer which is running full, there is a special case. Sewer, if that is running full, the R value will be equal to D by 4. D by 4. So diameter is 2 upon 4, value comes out to be 0.5 meter. Now I have everything. Let's calculate the discharge. Area is pi, N is 0.015 and R is 0.5 to the power 2 by 3. Discharge value is also given 2 and S is under root S. That's what we want to know. So from here, after calculation, S comes out to be 0.00023. So the correct answer is answer. Now let's move on to the fourth question. At the same mean velocity, ratio of head loss per unit length for a sewer pipe flowing full to that of the same pipe flowing half full, that we need to calculate. Okay, let's start. What they are saying is, first let's clear the area where we have to do the thing. Then they have given the same mean velocity at the same mean velocity. So V1 is equal to V2. The ratio of head loss H1 and H2 per unit length of the sewerage pipe flowing full to the of the same pipe flowing half full. See, same pipe, that means you have diameter 1 is equal to diameter 2. Okay, so, and they are saying that the ratio of head loss per unit length, that means H upon L, this value, if both we will divide 1 upon 2, then what will be the answer? Okay, see, we know that what head loss formula, head loss is nothing but FL V square upon 2GD, right? So the for first one, H1 is equal to FLV 1 square upon 2GD and H2 is equal to FL L2 L1 V2 square upon D1 2G D2. Okay, if I from here, if I get the value H1 upon L1, that is nothing but F V1 square upon 2G D1. Here everything is same, that is equal to H2 upon L2, because the thing is given that, see, F is the friction coefficient, will be same because pipe is same, right? And V1 is same, they have given, diameter is also same, they have given, 2G is common, so everything is same, and we can say the ratio H1 upon L1 divided by H2 upon L2, this ratio comes out to be 1. So the correct answer is option C. Next, an inverted siphon is a device for distributing septic tank effluent to a soil absorption system, device for preventing overflow from elevated water storage tank, or else device for preventing Crown corrosion of system, section of sewer which is dropped below the hydraulic grate line in order to avoid an obstacle. Alright, see what is inverted siphon. If I may draw it, so it looks like something this. That means sewer is coming at the same height, going out also at the same height. But let's suppose there is a obstruction in between, like a lake or river. So how can the sewer go from inside the water, right? There is water filled here. This is the water. Okay, now in this case we use inverted siphons. Inverted siphons are nothing but they are opposite of a normal siphon. Yes, and another thing should be focused, that the pressure here should be greater than atmospheric pressure. Pressure here should be greater than atmospheric pressure. Atmospheric pressure, it should be greater than that. Another thing should be keep in mind that it should run fully. It should be run fully, so that everything, there should not be, if it is not running fully, there can be some air gaps that will create problem in future. So the inverted siphon is nothing but the correct option matches with a section of sewer in which is dropped below the hydraulic grade line in order to avoid an obstacle. Option D is correct. Let's move to the sixth question. The drop manholes are provided in sewerage system when there is, see, manholes are what? Drop manhole is the one in which a vertical pipe is provided to allow for between the branch sewer and the main sewer. There will be a vertical pipe. There are branch sewers and there is main sewer. So in between they will allow a vertical pipe. What do they need to do? Okay, why do they provide drop holes? Drop manholes are basically provided when there is a change in elevation of ground. That means if ground, this is plain ground, and when the elevation changes, they have to put a drop manhole to for the future inspection if everything is going proper there or not. So, and one more thing it does, that it reduces the turbulence. There is branch sewer, there is main sewer. Before connection there will be some turbulence. The turbulence is reduced in the drop manhole when the elevation difference between the incoming and outgoing sewer is greater than 0.5. So whenever there is a change in alignment, then we will change in elevation, then we will put drop manhole. So option C is correct. Next is a combined sewer is one which transports, see, in some areas there will be two different sewage. One will carry sewage and another will carry rainwater, storm water. Okay, but what is combined? Combined is single large diameter pipe that will be provided, and in which sewage plus rainwater or storm water both will be transported. So it, because see, it will have initial costing, higher costing, but the maintenance will be less because we don't need to check both the pipes. There is only single pipe and that's running properly. Now the option that matches combined sewer is one which transports domestic sewage as well as storm water. So, and one more thing, there is storm water and still water as well. So everything it covers. So the option D will be correct. Let's move to the question number 8. The crown of the outgoing larger diameter sewer is always matched with the crown of incoming smaller diameter sewer. It eliminates backing up of sewage in the incoming of smaller diameter. Yes, the assertion is correct as well as the reason is correct. We have already discussed this type of question.